Hello and welcome everyone. I am Avinash Sahu, your physics guru, and today we will study about the chapter electricity. Okay, we know that electricity is an essential part of our life nowadays. It is controllable and convenient form of energy. That's why we use it in houses, schools, hospitals, industries. If we're talking about the modern industries, then electricity is not only used for lighting purpose, it also used for running machinery of the factories. It's used for traveling, it's used for information and communications systems. We use electricity for heating, and you can say that cooking also, we use electricity in cooking also. So we can say that electricity makes our lives more faster and easier. In this chapter, we study about the term electric charge and its property. Then after we study about the term electric current, its unit, and then we solve some numericals which is based on electrical current. First of all, we study about the term electric charge. Okay, electric charge. The symbol of electric charge is Q. Okay, the symbol of electric charge is Q. Then try to understand these terms. Suppose that I have a particle or a matter, okay, here, and it is at rest. Initially it is at rest when there is no electric field is here. Okay, I take a matter, or you can say that a particle is here and it is initially at rest, but when we placed it, or you can say that when we placed it, or when we found that we applied some electrical field here, then we found that this is in motion. Initially it at rest when there is no electrical field. Okay, there is no electrical field, then it is at rest. But when we placed here, or you can say that when we applied some electrical field, then it's in motion. And we know that who is responsible for the motion? A kind of force is responsible for the motions, and here is force is caused by the here, which is responsible for the force? A charge. Okay, actually charge is responsible for this force. Okay, so we can define the electric charge as it is the property of the matter. It is the property of the matter due to which it experiences a kind of force. Its force may be attractive or repulsive. Okay, this force may be attractive or repulsive. When you placed in an electric field, then you found that a force is acting on it. When you placed in electromagnetic field. What is the meaning of electromagnetic field, or simply electric field? Suppose I have some charge here, then there is a space around the charge where it experiences some forces. Okay, where the space around the charge where we place some another charge particle. Suppose the charge is capital Q and it's a source charge. Okay, then we found that if it is positive, then it repel, it means force is acting in it. The space around the charge where it acts, if we place the charge here, there is no force. Here no force is acting, that is, there is no area of the field, electric field. The space up to which it experiences a force, the space around the charge up to which this charge are able to exert some force on another charge, particles. Okay, so that space is known as electrical field. Okay, that space is known as electrical field. And if we place some charge in electrical charge body in electrical, then it's experience some force. Why this moves? if we placed here non-positive charge or negative charge, then there is no force of attraction or repulsion here, okay, because there is no charge. Then if we place some charge particle, then it exerts force. Then force is responsible due to some charge. So how we define the charge? Electrical charge is the property of matter due to which it experiences some force when it is placed in electromagnetic world. In simple way, in simple word, we can say that when you place some charge, it is in simple way how we define the electric charge. It is the property of the matter due to which it attract or repel by the another particle. Simple way. What is electric charge? It is the property of the matter due to which it attracted by or repulsive by the another charge particle. Okay. So what is the electric charge? Electric charge is the property of the matter due to which it experiences some forces when you placed in a electromagnetic force. Then this force is responsible. Then electric charge is responsible for this force. This property is known as electrical charge. Okay. Benjamin Franklin divide electrical charge into two parts, two kinds. There is two kinds of charges: positively charged or negatively charged. Benjamin Franklin divides these charges in two parts: a negatively charged particles or positively charged particle. There are two kinds of charge: negative charge or positive charge. Then how a body is said to be positively charged or negatively charged? Suppose that this is a matter, and if it emits loses some electrons, then and this electron and another matter gain some electrons. Okay, there are two things possible. If a matter loses some electrons or a matter gains some electrons, then what will happen when an object loses some electrons? Then there is less number of electron and body acquires positively charged, and those objects or body or matter which gain some electrons, that is known as negatively charged. Suppose that sodium, in case of sodium, okay, we know that the atomic number of sodium is 11. It means, and now it is neutral. Okay, now sodium is neutral. Why? Because there is number of electron is minus 11 and number of proton is plus 11. So net charge on it is 0. It means it is a neutral. But for stability, it's, if we're talking about electronic configuration 281, then it has one electron in outermost shell, but this sodium wants to be stable. Okay, wants to be stable. So it's lose one electron and becomes stable. Okay, it becomes stable. Then if it lose one electron from the outermost shell, then what will happen? The net charge of the sodium is due to the number of the electron is 10, so charge is minus 10, and number of proton is yet 11, so the net charge on it is plus 1. Algebraically, when you added it, the net charge on it is plus 1. This is neutral, but when it loses some charges, one electron, then it becomes positive. Then it becomes positively charged. Okay, then it becomes positively charged. Na positive. You can say that Na positive. In this way, because in this case it loses one electron, so it acquires positive charge. Same way, when electron loses, then it becomes positively charged. Okay, take another example. To show that how an object becomes negatively charged. Chlorine has atomic number 17. It means the number of electron is 17 and the number of proton is also 17. Now this is neutral. But if we talking about electronic configuration 28, which is 287, this chlorine wants to become stable, and it is possible only when it gain one electron. When it gain one electron, then what will happen? Its electronic configuration becomes 288. It means the number of electron becomes 18 and number of proton is now is 17. So net charge on chlorine is plus minus 1. It means chlorine has one negative charge. In this way, or you can say the chlorine negative. Okay, in this way you found that electron gets stable after gaining one electron. When it gains one electron, then it becomes negatively charged because number of electron is more when it gains and number of electron is less when it loses. So when the number of electron becomes less, then it positively charged. When more electron is added, then it becomes more negatively, it means negatively charged. So in this way there are two kinds of electric charge. Now we study about the term electric charge. Some properties is the SI unit of charge. The SI unit of charge. We measure electric charge. The symbol of electric charge is Q, and the SI unit, if we talking about the SI unit of electric charge, then it is coulomb. Okay, coulomb, and the symbol is C. Okay, and the symbol is C. Here C means coulomb. Okay, remember that when you write the full name, then the first letter will be small, and when you give the symbol, then its letter becomes capital. Okay, this is the symbol. Now discuss some properties of electric charge. What are the properties of electric charge? What are the properties of electric charge? Okay, so discuss it. Properties of electric charge. We discuss about the properties of electric charge. Then first property is electric charge is a scalar quantity. What it means? It means it has only magnitude, not direction. It means it has only magnitude. For example, you can say the 5 coulomb, 50 coulomb, then it has only magnitude, not direction. Okay, this is the first property. Second property, like and unlike charge. Okay, like charge means positive and positive, or negative and negative. Like charge repel to each other. Okay, like charge repel repel to each other, and unlike charge attract to each other. Unlike charge means positive, negative, or negative, positive. They attract each other. This is the second property. Like or unlike charge, okay, like charge repel each other and unlike charge attract each other. Next point saying that electrical charge is conserved. Electric charge are conserved. What it means? It means it follow law of conservation of charge. Law of conservation of charge. It means for an isolated system, okay, what is the meaning of law of conservation of charge? States law of conservation of charge. It means charge neither be created nor be destroyed, but it can be transferred from one body to another body, or you can say that the total charge before the interaction, after the interaction remains constant, or you can say that total charge, it means total charge for an isolated system remains constant. The law of conservation of charge says that the total charge for an isolated system remains constant. It means what it means, you can write here, okay, you can write down this topic, okay. Now law of conservation of charge. I am talking about the law of conservation of charge. Suppose that there are two object A and object B. This object is neutral. Neutral means the charge on A is, net charge on A is 0 and the net charge on B is 0. I am talking about the net charge, okay. What is the meaning of net charge? It means if I am saying that it is neutral, then it does not mean that it have not any charge. It has positive and negative charge but equal amount, so net charge is 0, okay. If I am saying that the total charge on the object A is 0, then what it means? It means it has the number of positive charge, the amount of positive charge and negative charge are equal, so net charge is 0, okay. In this case, so initially the net charge on A and B is 0, but we rub these two objects, okay, we rub these two objects, then what will happen? Then says that some electrons, says to 5 electrons are transferred from body A to B. 5 electrons are transferred from A to B. So net charge on A is net charge on, because electron are transferred, it means this charge, the body acquires positive charge because it loses electrons. So it loses electrons, the number of electrons less, so it has total charge is plus 5 electrons, okay, plus, because it lost. And this object gain some electron, okay, gain some electron. So charge on B is charge, okay, charge on B is minus 5, okay, charge on B is minus 5. So if we talking about the total charge of the system AB, system, of total charge is QA plus QB. Before rubbing, the total charge before rubbing is 0 plus 0, it means 0 charge, okay. But in this case, the total charge after rubbing, rubbing is QA plus QB, which is equal to value of QA is after rubbing plus 5, and the value of second, it means value of B object is minus 5. It means again it's also 0. It means before the rubbing its value is 0, and after the rubbing its value is also 0. It means law of conservation. This is known as law of conservation of charge. What is the law of conservation of charge? It says that total charge of isolated system, this system object AB and isolated system there is no any interaction of the external object. Okay, so this is the isolated system. We're not talking about the third object, which is okay. So for an isolated system, total charge remains constant. The total charge is 0, but after the interactions its charge on A body, because for 5 electron transferred, so net charge on this object is QA plus QB, which is 5 plus minus 5, which is equal to 0. Again it is 0. It means total charge before rubbing and total charge after rubbing remains constant. But we can say that some electrons are transferred from one body to another body. So this law states that, law of conservation of charge states that charge neither be created nor be destroyed, but it can be transferred from one body to the another body. Okay, it means total charge for an isolated system remains constant. Okay, this is the important property, that charge remains constant. So fourth point is, note down the fourth point. Fourth point is electric charge added algebraically. Total charge is added algebraically. It means, suppose a body has 3 charge plus 5 coulomb, another charge 2 which is minus 3 coulomb, and a charge Q3 which is again 10 coulomb. Okay, suppose there are 3 charges in a system, then calculate the total charge. It means total charge. Then this property states the electric charge is added algebraically. Algebraically means as you added in mathematics. Then total charge means Q1 plus Q2 plus Q3. It means plus 5, Q1 is plus 5, plus Q3 is minus 3, and Q3 is plus 10, which is equal to, add it algebraically. Algebraically is plus minus. It means plus 2 net. When you solve it, then it occurs plus 2, and when you added it plus, it means 12 coulomb. Okay, you added electrical charges added algebraically. It means, suppose that a body has 3 charge. When we transfer 3 charge on a body, then total charge on the body is 12 coulomb. Okay, last point. Now we discuss the last properties of electrical charge. Last properties of electrical charge states that the charge are quantized. Last property says the electrical charge is, fifth point, electrical charge is quantized. Electrical charge is quantized. What it means? The electrical charge is quantized means, it means suppose that here, suppose a body is A and this is body B, another body B. What is the meaning of quantized? Quantized means electron is always transferred in integral. Okay, multiple of integral. Integral means it may be possible that one electron is transferred, it may be possible two electron are transferred, it may be possible three electron are transferred, but it is not possible to in fraction form. It means half electron is not transferred from one body to another body. It is not possible. Okay, always electron transfer in multiple of integral. Okay, multiple of integral. Suppose that one electron, we know that the charge on electron, what is the charge on electron? Charge on electron is minus 1.6 into 10 raised to power minus 19 coulomb. Okay, charge on electron is 1.6 into 10 raised to 1 minus 19 coulomb. If one electron is transferred, then charge is due to one electron, which is equal to minus 1.6 into 10 raised to power minus 19 coulomb. 1.5 electron is not transferred. It means then if two electrons are transferred, then value is 2 electron means 2 into 1.6 into 10 raised to power minus 19 coulomb. Okay, it means minus 3.2 into 10 raised to power minus 19 coulomb. Okay, and suppose that, and so on, if 3 electron is transferred, then 3 electron is transferred, then 3 electron is transferred, then 3 into 1 minus 1.6 into 10 raised to power minus 9, and so on 4 5 6. Suppose n electron are transferred, then what's the formula? For 1 into में e, for 2 1 into में e, for 3 into में, for n, if n electron, then n into e. So this is the formula of quantization. Quantization means Q is equal to NE. What it means? It means that here n is multiple of integral. Integral means 1 2 3 4 5 6 7 8 9 10 and so on. Okay. So this is the first formula. Okay, first formula is Q is equal to NA. Okay, if electron is E is electron, then take minus, and if E is positive, then positive. Okay, if E is proton. Okay, if body gain electron, then use E as negative. If the body lose electron, then used E as positive. Okay, so Q is equal to plus minus Na. So this is the formula of total charge on a, how much charge. If I am saying that, okay, you can solve some numerical, then you are able to understand the topic. What, see in simple way, what is the meaning of quantization? Quantization means charge always, electron always transfer from one body to another in integral form. It means one electron may be transferred, 2 transfer, 300, 1500. It is possible, but in fraction form it is not possible. It means half electron is not transferred. Okay, so quantization means in the form of packets, 1 2 3. Okay, in the form of packets. Here some questions is calculate the charge on a body if 100 electron is transferred on a body. If 100 electrons are transferred on a body gain, you can say that a body gain 100 electron, then calculate the charge on it. If body gain 100 electron, then calculate the charge on it. Question is that if body gain 100 electron, then number of electron is 100. Okay, charge on one electron is 1.6 into 10 raised to power minus 19 coulomb. Okay, question is how much charge develop on a body? Then Q is equal to Na. Value of N is 100 into value of A is minus. Use minus because it gain electron, minus 1.6 into 10 raised to power minus 19. Here this is 19 and this is 10 raised to power 2. So answer is Q is equal to 1.6 into 10 raised to power. Okay. I solve here so that you are able to see. Okay, you are able to see what is inside the questions. Question says that if a body gain 100 electron, then how much charge is developed on the body? Then question is solve it like this. Q is equal to, we know that Q is equal to Ne, because 100 electron, it means 10 raised to power 2 electrons is gained by the body, and body gain electrons, so use minus 1.6 into 10 raised to power minus 19 coulomb. So answer is total charge on the body is minus 1.6 into 1.6 10 raised to power 2 minus 19. It means minus 1.6 into 10 raised to power minus 17 coulomb charge is on the body. Okay, minus 19 coulomb charge on the body. Okay, so this is the way to solve these numericals. Okay, now okay, now so this is the take another questions. Suppose question is how much electrons are required. Question is how much electrons are required. How much electron, it means number of electrons are required to develop 1 coulomb charge on a body. How much electrons are required? Question is that how much electrons are required to develop 1 coulomb charge on a body. Question says that this is body, and how many electrons we need? How many electrons we need to develop 1 coulomb charge? Then use this formula. Q is equal to Ne. So N is equal to Q by E. We want to develop 1 coulomb charge, and the value of E is, we know, 1.6 into 10 raised to power minus 19 coulomb. So coulomb is cancelled out, and N is equal to 1 by 1.6 into 10 raised to power minus 19. Okay, so it becomes 1.6 into 10 raised to power plus 19. This is in divided. This is divided when you use in upper. When you multiply it with it, then use the sign is changed and it becomes plus. Okay. Now solve this. N is equal to 1 by 1.6 into 10 raised to power plus 19. Okay, so when you remove this point, then we use 0. Okay, and we can write these equations like this. Remove one more 10. Okay, we like is 10 100 upon 6 into 10 raised to power 18. When you solve this, then you get this form, and the value of 100 upon 16, remember this point, value of 100, when you divided 100 by 16, then you get 6.25. okay, when you divide 100 by 16, then you get 6.25 into 10 raised to power 18. So this is the answer. This electrons, 6.25 into 10 raised to power 18 electrons are required to develop 1 coulomb of charge. So large amount of electrons are required to develop 1 coulomb charge. So this is the topic of electric charge. But electric charge, its unit is coulomb. There are two types of charges, positive charge and negatively charged. Okay, there are some properties of electric charge in which like or unlike charge, like charge repel each other, unlike charge attract each other. It is the scalar quantity. SI unit is coulomb. It's add algebraically. Okay, it follows the law of conservation of energy, law of conservation of charge. And last point is electrical charge are quantized. Quantized means always flow from in the form of 1 electron transfer, 2, 3, 4, 5. It is not possible to transfer 1.5 electrons, 2.5 electrons, 3.5 electrons. It is not transfer. Okay, so it is always transfer in the form of multiple of integer. Okay, so you can say that then we solve some numericals over it. So this is the part of electric charge.